In this lesson, we're going to look at triangle congruency, that is, proving two triangles are congruent using three different theorems: side, 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 angle, side, hypotenuse, leg. In this video, we're going to look at just side, side, side. So, if you look at the triangles in your packet, I have marked CB congruent to DF, AC congruent to ED, and AB congruent to EF. So since I have three sides of one triangle congruent to the three sides of a second triangle, they are congruent. Now what I did here is I matched up their angles, the corresponding angles. A corresponds to E, B corresponds to F, and C corresponds to D. So this is my congruency statement, and it's by side, side, side. And it's very important that your congruency statement is correct. Okay. All right, if we look down at example 1, we're going to use the same kind of technique where angle A corresponds to angle X, and from our previous unit, we know that the side opposite the angle, they're grouped together. Angle B corresponds to angle Z. So their associated sides are across from there. And then angle C corresponds to angle Y. So based off our diagram, we are given that AB is congruent to XZ, BC is congruent to ZY, and AC is congruent to XY, given. Remember, your first reason will always be given. So now that I have three sides of one triangle congruent to three sides of another triangle, I have congruent triangles. And again, you need to have this in proper order. Triangle ABC is congruent to triangle XZY. And if you highlight them, it helps you keep the congruency statement correct. We have two things I want to introduce here. Reflexive property. It's a very powerful tool when you're doing proofs. And it basically says that a line segment is congruent to itself or an angle is congruent to itself. The other thing I want to introduce is CPCTC, which stands for corresponding parts of congruent triangles are congruent. And this is what you're going to use if you're asked to prove that corresponding angles are congruent or corresponding sides are congruent. This is important here. Before you can use CPCTC, you have to show that the two triangles are congruent. If you have not shown that the two triangles are congruent, then you cannot use CPCTC. So let's look at a couple of examples. Example 2, we are given this diagram. And I'm just going to highlight a few things. Notice that JK and LM have the same tick marks. And JM and KL have the same tick marks. Well, that means that these pairs of sides are congruent. And as always, our first reason is given. Notice that both of the triangles share side JL. I'm going to mark that congruent because JL is congruent to itself using the reflexive property. Okay, so notice now I've got three sides of this triangle congruent to three sides of this triangle. So I have triangle JML is congruent to triangle LKJ by side, side, side. Now example 3. We're going to take this proof from the very start. So there's a few things that are important to do. Look at your given. We are given that U is the midpoint of YX and WV. And from previous lessons, we know the midpoint separates a line segment into two congruent parts. So that means that YU and UX are congruent to each other, and WU, UV are congruent to each other. We are also given that WY is congruent to VX. So notice, these segments are congruent, these segments are congruent, and these segments are congruent. So we have satisfied the side-side-side theorem. So now we need to fill in our proof. If our first reason is always given, we're going to just copy what was given to us. U is the midpoint, and I'm going to abbreviate midpoint, of segment XY, WV, and WY is congruent to VX. That's given. Okay? Now, we have to state, just because it's the midpoint, we have to state that these two segments are congruent and these two segments are congruent. So our next statement could be YU is congruent to XU and WU is congruent to VU. And we know this is true because we are using the definition of midpoint. A midpoint separates a line segment into two congruent parts. Okay? So now we've established that we have three congruent sides. So I want to make sure I do my congruency statement properly. So across from here, I have X, and across from here, I have Y. Those two angles correspond. With my orange, notice it's coming to two angles here. So it's V and V. I'm going to do it that way. And then across from the blue, I have W and V. So I'm going to start with this triangle over here. Triangle YUW is congruent. I'm going to start again. I went from my green to my green, and your color may be different, but it's congruent to XUV. Triangle XUV. Why? Because side, side, side. Now we can state that angle Y is congruent to angle X because corresponding parts of congruent triangles are congruent. And again, I want to restate, you must show triangles are congruent before using CPCTC.